In this video, we'll go over how to write equations of the ellipse in standard form. Why would we want to write an equation in standard form? Standard forms of equation tell us key features of graphs. By interpreting the standard form of an equation, we can bridge the gap between geometric and algebraic representations of figures. We are able to write the equation of an ellipse centered at the origin given only the coordinates of just one focus and vertex because ellipses are symmetrical. Remembering that an ellipse has a center, vertices, co-vertices, foci, and a major and minor axis. We'll be able to identify all these key features from the standard form of the equation. There are 4 variations of the standard form of the ellipse. We must know where the center of the ellipse is located. Is it at the origin or elsewhere in the Cartesian plane? Is the ellipse horizontal or vertical in the Cartesian plane? So is that major axis parallel to the x-axis or the y-axis? The standard form of an ellipse centered at the origin, the point 0, 0, and with a major axis on the x-axis is x squared over a squared plus y squared over b squared equals 1, where a is greater than b, the length of the major axis is 2a, the coordinates of the vertices are positive or negative a, comma 0, the length of the minor axis is 2b. The coordinates of the co-vertices are 0, comma, plus or minus b. And the coordinates of the foci are plus or minus c, comma 0, where c squared equals a squared minus b squared. Take a look at the standard form of an ellipse centered at the origin, the point 0, 0, with a major axis on the y-axis. X squared over b squared plus y squared over a squared equals 1. When we have an ellipse centered at the origin and the major axis is on the y-axis, the b comes before the a. If it is centered at the origin and the major axis is on the x-axis, the a comes before the b. In both instances, the equation is set equal to 1, and in the numerator, the top part of our fractions, we always have x squared plus y squared. It's underneath in the denominator where things change. Take a look at these 2 images. On the left, we have an ellipse centered at the origin with the major axis corresponding to the x-axis. On the right, we have an ellipse centered at the origin where the major axis corresponds to the y-axis. I'm just noticing the different shape that these ellipses have taken. Moving on to an example. Write the equation of the ellipse centered at the origin given vertices positive negative 8, comma 0 and foci positive negative 5, comma 0. Step 1. Where does the major axis lie? Notice the foci are of the form plus or minus c common 0, which means they lie along the x-axis. Plus or minus c is in the x position when we have an ordered pair x, comma, y. Because the foci lie along the x-axis, we now know the standard form of the equation will be x squared over a squared plus y squared over b squared equal to 1. Step 2. Determine values for a and c. The vertices are positive negative 8, comma 0, so a equals 8, and a squared equals 64. The foci are positive negative 5, comma 0, so c equals 5, and c squared equals 25. So far, we've gotten the a squared piece of our equation in step 2. Step 3, we determine the value of b. We know that c squared equals a squared minus b squared for any ellipse, which gives us 25 equal to 64 minus b squared. Solving for b squared gives us 64 minus 25 equals 39. We now know that b squared equals 39. We've found the b squared portion of this equation. We're going to plug that in step 4, and we get the resulting equation. X squared over 64, that was our a squared, plus y squared over 39, our b squared, equals 1.